I'm trying a new screen recording technique today, so let me know how the lag goes, if it's still off or if it's better or what's going on. Okay, so we're getting to section 3 now where we have arcs and chords. So before we had chords, but we talked about central angles and chords. Remember that, and I can kind of throw this up here. Central angles are equal to arc degree. Okay, so they are exactly the same. Remember, central chord means that it is, or central angle, I'm sorry, means that the vertex is at the center of the circle. So when we get into this, we have two vocab words, inscribed and circumscribed. I'm sure you all have heard of the word inscription, right? Where you get a necklace or a ring or maybe a book or something, and an inscription is either something written in or engraved, something like that. So if you were talking about in terms of geometry with inscribed, we're talking about the shape that's on the inside. So there will be two shapes. The one on the inside is the one that is inscribed. The one on the outside is the one that is circumscribed. Okay, so if we move on to the next portion, you will see two different figures here. So we have a pentagon and inside a circle. So in this figure over here, in figure 1, we have the pentagon is inscribed. So see this one because it's inside the other shape where the circle is circumscribed. Now using those same two shapes, I have made the circle inscribed, so now the circle's on the inside, and the pentagon is circumscribed, which means the pentagon is on the outside. Okay, so that's your second figure. So when we say circumscribed, we're just talking about it being on the outside. It doesn't mean it has to be the circle. It just means whichever shape is on the outermost part of our figure. Okay? Now we have a couple of theorems. The first one that we're going to talk about is two congruent chords form two congruent minor arcs. So let's say I go ahead and put this arc in on this circle right here. Okay? Now you will notice that yes, this is a straight line and we know the line is 180 degrees. But this arc, okay, so that arc is not equal to 180 degrees because it does not go through the center. And I guess we can add of the circle. Okay, it doesn't go through the center of the circle, so we do not call it, or we don't say that that arc is 180 degrees. Remember, it's only central angles that have the exact same measurement as the arc that it forms. Okay, so if I take this arc and I'm going to first copy it, and so here's another one. So I just copied it. They are the exact same line. And then I'm going to transform it, and let's say I want to flip it in the x-axis. So now it goes this way. Okay, so it's still the same one. All I did was transform. And then I'm going to put it over here and connect it with two endpoints on the circle, because remember that's how you make a chord, two endpoints on the circle. And what you'll notice is that the two arcs that are formed, so the first one over here, and then the second one over here, have congruent degree measurements. Okay, and it will always work that way. So you think about when people draw a picture of a baseball, they always have the stitches and where it's actually sewn together. You'll notice it's always the same distance from the side. So if you look at a two-dimensional figure of a baseball, the actual stitching itself will be the same distance from the side. So they'll have the same arc degree measurement. Now another one would be if a diameter or radius is perpendicular to a chord. Okay, so diameter, radius, whatever, it is perpendicular to a chord. So if I just draw a chord in here and I make it perpendicular, and I'm just going to have to make a bit of an estimation. But if this is perpendicular, what do you notice about the chord itself and the arc? Well, what happens is it cuts the arc in half, exactly. So if from here all the way around to the other side was a total of, let's say, 36 degrees, then that would mean each of these arcs are 18 degrees in their measure. Now remember that this angle right here is not a central angle. Okay, so be careful. This angle is not 18 degrees. It's another 90-degree angle, because when you have 190, all of these come out to be 90-degree angles. Okay, so it's not central. It's not the same as this arc over here. And this is what I was telling you in class, is that you have to be careful, because you will start to have angles that are not central. So make sure you're paying attention to where that vertex is. So that would be another theorem. Now also, if it isn't a diameter, and let's say it's just a radius, well, I can shorten that up and go there. Well, what's the difference? It's only half of the distance on the other side. There's nothing different at all. Or let's say I did this and shortened it up and made it here. Well, as long as we know that this is perpendicular, then we know for sure we can extend it. It'll be a radius. It cuts this in half. Oh, that's the other thing I forgot to mark in there, sorry. It cuts the chord in half. It cuts, if we extend it, it would eventually cut the arc in half. So all of these things work. I can tell you that we will be doing something with right triangles with this information, but that's all I'm saying, because I'm going to make you kind of flounder a little in class and see what you can figure out. Alright, if two chords are equidistant from the center, then they are congruent. So you'll notice these two chords here, I drew those. And now remember, when we're measuring distance, distance is always perpendicular. You go straight there. If you want to know how far you are from something, you're not going to measure on an angle, you're going to go straight to that exact point that you're looking at. So what ends up happening is you measure that distance, it's perpendicular, and if you know that those are the same, then we know that this chord, let's call it AB, for instance, would be congruent to CD. Okay? Also, remember from the last information we were talking about, the last theorem, because it's perpendicular, it also cuts those into congruent parts here and here. And then, of course, if we continued it, it would end up cutting the arcs in half too. So remember, all that stuff kind of all fits together. It's pretty nice. All right, so that's it for our third section. Our fourth section, we have inscribed angles. I'm not going to give you a whole lot of information with this, because I am going to make you do a lot of exploration stuff in class. Okay, so just kind of take what I give you, and then we'll do some more when you get here. So our first word is intercepted, and that is an arc formed by a given angle. Now, intercepted is really important because you will see it a lot, and if you don't know what it means, you'll get really confused. So if I was talking about angle CED, okay, so angle CED, that makes what arc? Well, it makes arc CD, and remember, you draw an arc over those. Okay, so what that means, the way that you could use this vocab word intercepted, is that CD is intercepted by angle CED. Okay? Easy, right? So it just means the arc that the angle forms. Now, of course, if we go down to our second one, we have another angle right here, BFA. Remember, this right here, not central. Okay, this is not a central angle. Very important. The vertex is not at the center. So again, instead of it being CD is intercepted by CED, we could say arc AB is intercepted by angle AFB. Okay? Pretty easy, right? I don't think it's so bad. Alright, well, now it's time to dance. Alright, get up and dance, guys. I hope you knew what song that was, because if not, then I'm getting really old. Alright guys, see you later.